Hello guys, welcome back to TechDose, and in this video we will look at number of people aware of a secret problem which is from Leetcode number 2327. We will start with the recursion approach and try to optimize it by using memoization, and then we will also be looking at the tabulation approach. So this is a dynamic programming solution and it will be beginner friendly. So if you want to learn dynamic programming, then you can do this problem. Now let's look at the problem statement. On day one person discovers a secret. You are given an integer delay, which means that each person will share the secret with a new person every day. Starting from delay days after discovering the secret, you are also given an integer forget, which means that each person will forget the secret days after discovering it. A person cannot share the secret on the same day they forget it, or on any day afterwards. Given an integer n, return the number of people who know the secret at the end of day n. Since the answer may be very large, we have to take modulo 10 to the power 9 plus 7. If you look at the first example, then you have n equals to 6 days and the delay is 2 and the forget is 4. Now let's say that if a person has to start, like let's say if a person 1 has to start, then he can actually know the secret on day 1. So let's say this person is A and he will be knowing the secret on day 1. The first person will always be knowing the secret on day 1. Okay, because why to delay the information being shared to the first person? The earliest period is day 1. So I will always be sharing the secret with at least one person on day 1. Now since the delay period is 2, at day 2 only A will be knowing the secret. There will be nobody else, because A will not be able to share the secret until the delay period is over. Okay. So if you add the delay period, when A came to know it was 1, and if you add delay period it will be 3. That means starting from day 3 only A will be able to share the secret. So if A shares the secret after let's say delay period, then it will be sharing on day 3. Let's say it shared to B, right? Now B knows the secret on day 3, and at day 4 it will be sharing to, let's say, C. After this it will not be able to share because A will be forgetting about the secret after forget period. Okay, what is this forget? So you will see that whatever is the day on which A came to know, let's say A came to know the secret on ith day, then he will start sharing the secret from I plus delay day. And he will be forgetting everything about the secret on I plus forget day. So on how many days A is actually holding on to the secret and actually spreading? It will be spreading from I plus delay to less than I plus forget day, isn't it? So if A came to know about the secret on day 1, then it will be able to start sharing from 1 plus delay days. That means it will start sharing from 3 days, and it will forget on 1 plus forget days 5. So that means A will be sharing the secret from 3 to less than 5. So yes, A has shared to everybody he could have shared. Now let's talk about B. Again, B will have the delay of 2. So it will be sharing to, let's say, 5. On day 5 it will be sharing to another person D. And it will be sharing to another person on day 6, which is E. Now on day 7 it cannot share because it will be outside of the range of I plus forget. 3 plus 4 will be 7, and so the range should be less than 7, right? Now for this person C, it will be sharing in 4 plus 2, that is 6 days. So on 6th day, let's say that it has shared to person F. It can also share on 7th day, but you know that 7 is outside of the range of this n value, so we will not be considering that. Okay, and here we will stop. If you talk about D, then D can also not share because the next time that it can share will be 5 plus delay period, which will be 7. So at this point of time, if you look at this tree diagram, then on nth day, who all know the secret? On nth day, D, E, F will know the secret, B and C will also know the secret, but A will not know the secret because A has forgotten when the day is 6, right? So how many people know the secret? 5 people, B, C, D, E, F. and therefore the answer is 5 here. If you look at the answer, it will be 5. Okay, so this is how the answer has been computed. Now you can see here that, I mean, if you see there is a 6 and there is another 6. Why I am assuming that they are two different people? Because I will always try to maximize my spread. So if B has to tell somebody and C has to tell somebody on the same day, they will definitely be picking two different people to spread to maximum number of people, right? And that is why even though this node has 6 and 6 day, they will be spreading to two different people. That's what I will be assuming. If you think about why B is included, then you should also think that on this day 6, what will be the period in which people will be knowing about the secret? So on day 6, if somebody knows about the secret, then they will be forgetting about the secret only on n minus forget day. So what is n minus forget? The n value is equals to 6, forget value is 4. So n minus forget, 6 minus 4 is 2. So after this day 2, everyone will be knowing about the secret. So after this day 2, all these 5 nodes are actually covered, B, C, D, E, F. But A is outside of the range, isn't it? It is less than equals to 2, and that is why it will not be considered. So this is the important part in understanding the problem. I think it is clear now. And once it is clear, then let's look at the constraint here. N value is ranging from 2 to 10 to the power of 3. Okay, so we cannot write an exponential algorithm. We cannot write an n cube algorithm as well, because n cube will be 10 to the power of 9, which will not pass within your 1 second, because 1 second is 10 to the power 8 computations. So I should write an n square algorithm approximately, or n square log n, but nothing more than that. So we know about the expectation of complexity, and here delay will always be less than forget, and they both will be in the range of 1 to n. So all are positive numbers. So having understood this, let's now look at how to solve this problem by the intuitive recursion approach. Let's try to take an example with n equals to 7, delay equals to 2, and forget equals to 1. So in the recursion approach, we will be starting always with day 1, right? On day 1, I will be starting, and I will be checking that if this is outside of the range of n minus forget, then it will not be contributing anything to the count. So I will be making 0 contribution for this if it is outside of n minus forget. What is n? N is 7. What is forget? It is 4. So if this value, like whatever is the index, if it is less than equals to n minus forget, then it will not be included in our final result. And if this is true, then the count contribution of this is going to be 0. Otherwise, it will be contributing 1 person to the final count. That means this person will be knowing the secret at the end. Okay. So initially I know that the count contribution here is going to be 0, because 1 is outside of the range of n minus forget. Here n minus forget is 3. So if the value is less than equals to 3, it will not contribute. But it can always spread the secret. So where will it spread? It will start its spread from, if the current index is, let's say current, or let's call it I, then it will start its spread from I plus delay to less than I plus forget. That will be the range in which it will try to spread the secret. So from 1, the delay period is 2, so it will spread to 3. It will also spread to 4, and it will also spread to 5. Will it spread to 5? If you look, the value of I is actually 1, and the forget is 4, so it should be less than this value 5. So we are done. Now this first person cannot spread to any other person, and let's say that day is equals to person, because on each and every day we will be spreading to different people. So this person A cannot spread beyond this point. Now let's look at this 3. Now this 3 is also less than equals to this range 3, right? So this will also be having 0 contribution, but it can always spread. And where it will be spreading? It will be spreading from 3 plus delay. That means it will be spreading to 5 and 6, because the range difference between forget and delay is only 2, right? Now it will not be going to 7. The n value is 7. Now you look at this 5. Will it be contributing anything? Yes, because it is greater than this value 3. So within the range of n minus forget plus 1 to n. So it will be knowing the secret by the end. So its count contribution will be 1. And it will be trying to spread from 7 to 8. But then 8 is outside of the range. So that call will not be made. That is invalid. And therefore we will stop at 7. At 7 the contribution is going to be 1. From 7 we will not be making any other calls. And so the return value from here is going to be 1 value. Now from 5 we cannot spread to 8 definitely. So the return value is going to be the count contribution of 5 plus this one, which is going to be 2. From 3 actually we can go to 6, but from 6 we cannot go to 8 because that will be outside of this range. So the count contribution here was 1 because this is a person who will know the secret by the end, and so it will be returning a 1 value. This 3 will be returning 2 plus 1 plus 0, which is 3. On the right hand side if you see, then we are at 4. And will this person know by the end? Yes, he will be knowing by the end because it is greater than 3. So count contribution will be 1. And from here the spread will happen to 6 and the spread will happen to 7. 6 is also within the range, so count contribution is 1. So this will be returning 1 because we cannot make further calls to 8. That will be outside of the n range. Similarly, this count contribution will be 1 and this will also return 1. So this 4 will be returning 1 plus 1 plus 1, which is going to be 3. And this one will be returning 3 plus 3 plus 0, which is 6. So this is our recursion tree diagram, which is showing clearly about how are we going to count the number of people who will be knowing the secret by the end. So for n value equals to 7, delete 2 and forget 4, the answer is going to be 6. Now if you carefully analyze this problem, then we will get the exact same count when the day is same. So if we encounter the same day, the count is not going to change. For this day 6, the count returned was 1, and on this day 6 the count returned will be 1. Okay, if we expand the solution and increase the number of days, you will see that there will be more repeating subproblems. This is also a repeating subproblem. Here whenever the day is matching, then the count returned will always be the same. It cannot change. And since I know that there is only one variable, which is day, which will be defining the total number of people who will be knowing the secret beyond this point, therefore I can apply memoization on this entire solution, on this entire recursion solution. Why the recursion will not work? The recursion will not work because the branching here, let's call this k factor. If it is kind of a binary tree, then you can expect 2 to the power n number of nodes in the recursion. But this is not a binary tree. Okay, the branching will depend on what is the value of forget minus delay. And let's call this k. Then the total number of nodes will be order of k to the power of n, and that will be considered as the time complexity, right? So definitely this is an exponential solution and it is not going to work. We have already seen in the constraint section. And therefore if we know that there is only one variable which defines the result, then why not save it? Why not save the result? So what we will do is we will create a table of size n value, which will be ranging from 0, 1, 2 and go till 7. And whenever we find the total count for a certain value, like let's say for this 5 I find that the count is 1, for 6 I find that the count returned is 1. Then next time when I find 5 or 6, and if I see that it has already been calculated, then I will be simply returning it without having to parse the entire subtree. So it will be trimming out. Okay, and in that way it will be providing an optimization. Now in this entire table, since it is counting cannot be less than 0. It is impossible. So I will be taking this memoization table and I will be initializing it with all -1 values, saying that if you see -1 for a particular subproblem, then this means it has not been solved, and so you need to solve it by using recursion. But if you see that the value is not -1, it is some positive value, then you need to return the count. That is how we are going to solve it. So this is the entire memoization approach, and if you do that, then there will be n number of unique problems, but you know that we will be iterating through each of the branching, so you can say that it will be nk. K's maximum value, forget minus delay, can go till n, and so the time complexity in the worst case can become order of n square. Okay, and the space complexity is going to be order of n. I hope the recursion memoization is clear. So before looking at the tabulation approach, let's look at the code for this recursion memoization. Now in this case we are given the n value, delay and forget. So I'm defining the mod, which is 10 to the power of 9 plus 7, the max value, which will be defining the maximum reachability, because from any given index I, if you want to spread, then it will be starting from I plus delay, and it should be less than I plus forget, isn't it? Because if ith person forgets about the secret, then he will not be able to spread it anymore. The max value is n, that means I should not go beyond n, and the memoization table will be initialized with all -1 values, and I will be calling the count recursion function. In this case, if the solution is already computed, then just return the solution. Okay, the current is exactly the day number. So if that particular day have already been seen in the recursion tree diagram, then simply return the solution, the count value. Otherwise, the total will be computed, and we will see if in the final result, if this current node will actually be remembering the secret, that means the current person will be remembering the secret, then we will be assigning it a 1 value, otherwise we will be assigning the 0 value. So if this condition is true, it will be assigned as 1. If this condition is false, it will be assigned 0. After this, we will be trying for this current node, we will be trying for all the branching, and the branching will start at current plus delay, because I is equals to delay. So current plus delay, and it will go to less than current plus forget. It will go to less than current plus forget. And if at any point the current plus I is exceeding the n value, then we will be breaking out. Otherwise, we will be taking the total count returned from each of the branching, and we will be continuously adding and taking the mod of 10 to the power 9 plus 7. And finally, before returning the result, we will be storing the value in the memoization table, so that the next time when I arrive to this same day, then I don't have to go through the entire recursion, but simply I will be returning the pre-computed result. Okay, so this is the entire recursion memoization approach. I hope it is clear. Now in this case, I have already told you that if, let's say, the ith person has to be informed, let's say the ith person has to be informed about the secret, then who all can inform the ith person? It will be informed by a person starting in the range of I minus delay to somebody who is to the right hand side of I minus forget, isn't it? Because only in this range of I minus forget plus 1 to I minus delay, these people will be the one who will be informing the ith person about the secret. If this I value is n, then I will say that the value d here will be n minus forget, and the value f here will be n minus delay, if the I value is n. Okay, so the d plus 1 to f can share the secret with the ith person, and that is how we will be thinking it in terms of a sliding window problem. Because if I say that the ith plus 1 person has to be informed about the secret, then who will be informing? You take one person to the right hand side, and you leave this d plus ith person, but take the range from d plus 2 to f plus 1, and they will be informing to the I plus 1th person, right? If I talk about I plus 2th person, then this d plus 2 cannot inform. Take from d plus 3 to f plus 2, and this will be the range of people who will be informing to I plus 2, right? So you see how this window is sliding, and the count of people who are present in the window, let's call it the window count. The count of people who will be present in the window will all be eligible to inform this I plus 2th person. So if I have to ask who will be informing the nth person, then there will be a window count number of people who will be able to inform the nth person. So finally my answer will be the sum of these count of people in the windows who can actually inform to this nth person, right? So if you want to maintain this count, then you know that whenever you slide a fixed size window to the right hand side, you add the next number and you subtract the number which is lost. This is how you slide, right? So we will be solving this by using sliding window and dynamic programming on top of it. Since you have already solved it by using recursion, this will be very easy for you to understand. Let's take an example of n equals to 7, delay 2 and forget 4. Now in this case, if I have to take all possible days, then you know that the possible days will range from 0 to 7, which is of n plus 1 size. Right, so I have defined a DP table, pre-initialized all the cells with 0. I am not writing the values, but they are all zeros. Now DP at 1 will be written as 1. This means that at day 1, one person will be knowing about the secret. That is for sure. Okay. Now we will be starting from this day 2. Now who all can inform this person present at day 2? Who all will be informing this person? So this person can be informed from I minus delay to somebody lying to the right hand side of I minus forget, isn't it? We have seen this in the diagram. Somebody to the right of I minus forget, that means I minus forget plus 1 to I minus delay. So if this is, let's say, our loop I will maintain the window counter, okay, and it will start with the value 0. I'm starting with this 2. So who all can inform 2 minus the delay value 2? It is 0. So if I minus delay is greater than 0, then I will be adding those number of people in the window count, because that will be the new addition. Okay, we are sliding one time to the right hand side. But since I minus delay is not greater than 0, so it will have no contribution. And similarly, if you slide a window to the right hand side, this is your I minus delay, because what happens is, if the previous index was I minus 1, so for that the I minus delay value would have been here. But if you go to the next position, which is the ith index, then the I minus delay value will shift one time to the right. So this value needs to be added. Okay, but it can only be added if it is within the bound of the array. Okay, so if it is out of bound, then we cannot actually add, because it is invalid day. And similarly, now if you look at the left hand side, for this I minus 1, if this was your I minus forget, then for this I, this will be the I minus forget, which you need to remove when you slide to the right hand side. So if I minus forget is also within the bound, then only we will be removing, otherwise we will not. So our window count is not going to change, it will be 0. So write a 0 here and move forward. Now for this 3, see the I minus delay is 1 and I minus forget will be 3 minus 4, which is out of bound. So just see this value and add it into your window count. Okay, and finally your DP at I will be updated with 1. That means the third person will be informed by only one person on the left hand side, or you can say by only one person. If you go to this 4, then 4 can be activated from 2 and to the left of it until you reach to I minus forget. So the value here will be adding whatever is the value here. So this is 0, 1 plus 0 is going to be 1, and I minus forget value is 0. Since it is not greater than 0, therefore we will not be subtracting anything. So here also you will write 1. That means only one person can activate this 4, which will be this 1. 1 will be activating this 4. Now we will be going to 5. Again repeat the same process. Look at I minus delay 3. Add this value, because we are sliding the window by one time. So if you add, it will become 2. And you need to subtract the I minus delay value, because that is going out of bound. So this 1 needs to be subtracted. So here the value will be 1. That means only one person will be activating this 5, which will be this 3. Right? And now you go to the right hand side 6. So look at this I minus delay. So this value is 1. Add this one value, it becomes 2. And I minus forget, so this value is 0. So 0 will be subtracted, it will remain as 2. That means 2 people will be informing on day 6, and that will be 4 and 3. Now you move forward to this 7. Look at this I minus delay, which is this 1 value. So add 1 value here, which makes it 3, and look at this I minus delay. Here also you are seeing 1. That means you will be losing one person. One person will forget about the secret. So this makes it 2. So write 2 here and you are done. Once you are done, on each day, how many people will be actually informing are written. That means if on day 6, 2 people are informing, that means 2 new people will be informed on day 6. Okay, it can be two different people X and Y. It has to be 2 different people because we want to maximize our count. Similarly, on day 7, 2 extra people P comma Q can get informed. So by nth day, where n is equals to 7, how many people will be knowing about the secret? You know that in forget time, people will be forgetting about the secret. So if all these assignments were new people, then I can tell you that at this point 7, all the entire people who are present from this index 3 and to the left hand side, that means all the people who were informed till this index 3 will all be forgetting about the secret, and only from n minus forget plus 1, only from this index 4 and beyond this, everyone will be remembering it. So what we have to do, we have to just iterate and keep adding these values. 1 1 2 2 is going to be 6. Therefore 6 people will be knowing about the secret by the end. Okay, now using this sliding window approach, we have updated each of the index value in just one time. And how many indices are there? Order of n. So in order of n time we fill the table, and after that we have just added the last part, which is simply your n minus forget number of items. So I will just add n, because if forget is equals to n size, then I will add n, and that will make it order of n solution. And the space complexity is also order of n because of the table. I hope this optimal approach is also clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, we are given the same n, delay and forget, and we are taking the mod 10 to the power 9 plus 7, and we will be defining the DP table from 0 to n and pre-initializing with all the values as 0. DP at 1 is 1. The window count is 0 initially, and we will be iterating from day 2 till the last day, nth day. On day 1, I will always be assuming that the first person will be informed. This is the same piece of condition that I had written. If you are sliding to the right hand side, then add the next value and subtract the previous value if they are within the bound. Okay, and simply update your DP at current with the range sum of the window. That is what we are doing, and finally we have to add the number of people who are actually remembering the secret and simply return the final value. If you look at the modulo arithmetic, whenever you do subtraction, you have to offset using the mod so that you don't get a negative value. So that's it about the entire solution. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.